January 10th, 1954. High above the Mediterranean Sea, BOAC Flight 781 simply ceased to exist. It would take weeks for the true horror of the event to surface. When the Royal Navy eventually pulled the shattered wreckage from the sea floor off the coast of Elba, the physical evidence they recovered was deeply unsettling. Investigators combing through the debris found cabin carpet impossibly wedged into the tail section. They found smears of seat paint dragged violently across the outer rear fuselage. Most chillingly of all, they discovered the precise imprints of coins stamped directly into the metal fuselage panels. Autopsies of the victims quickly confirmed the worst. Medical evidence showed ruptured lungs across the board. This was not a mechanical failure of an engine or a catastrophic pilot error. It was explosive decompression. The world's most advanced aircraft had violently torn itself apart in clear skies.
To understand how a brand new commercial airliner could simply explode in midair, we have to rewind to the years between 1946 and 1948. The British government had issued an ambitious requirement for a pressurized jet airliner eager to dominate post-war skies. The de Havilland Aircraft Company answered the call, pouring their engineering might into the development of the DH-106 Comet. The leap in technology was staggering. Up to this point, commercial piston-driven aircraft cruised at around 20,000 feet. The Comet was designed to fly high above the weather, cruising between 35,000 and 42,000 feet. On July 27, 1949, test pilot John Cunningham successfully flew the Comet prototype on its maiden flight. By May 2, 1952, BOAC initiated the world's first commercial jet service, flying passengers from London to Johannesburg. But this incredible leap in altitude brought extreme physical demands. To keep passengers alive and comfortable in the thin atmosphere at 40,000 feet, the Comet had to maintain a massive internal cabin pressure differential of over 8.25 psi. That 8.25 psi pressure differential placed unprecedented strain on the aircraft. Every single time the Comet took off and landed, the thin aluminum fuselage underwent intense cyclical expansion and contraction. Exactly 1 year after commercial service began, the first warning sign appeared. On May 2, 1953, BOAC Flight 783 crashed shortly after takeoff near Calcutta during a heavy thunderstorm. Investigators looked at the wreckage and officially attributed the crash to severe weather or pilot overcorrection. The deeper structural reality remained hidden. Then came the doomed Flight 781 over Elba in January 1954. Captain Alan Gibson was in command. Mid-flight, he initiated a routine radio transmission to Captain Johnson, who was piloting a BOAC Argonaut nearby. Gibson's message cut off mid-sentence. The Elba disaster sent shockwaves through the aviation industry. The Comet fleet was temporarily grounded. The Havilland and BOAC rushed to make preliminary modifications, and by late March 1954, the jets were cleared to return to service. It was a fatal miscalculation. Just weeks later, on April 8, 1954, South African Airways Flight 201 crashed near Naples. The circumstances were nearly identical to Elba. The British government immediately revoked all Comet airworthiness certificates. The fleet was grounded indefinitely. Back at de Havilland, Chief Designer R.E. Bishop and Chief Structural Engineer R.H.T. Harper were baffled. They had tested their designs extensively. To solve the mystery, the Royal Navy managed to dredge up approximately 75% of the Elba wreckage from the deep water. The twisted metal was transported to Farnborough. There, E.L. Ripley, an investigator with the Royal Aircraft Establishment, or RAE, began the painstaking task of reconstructing the shattered airframe on a massive wooden framework, hunting for a ghost in the machine. Sir Arnold Hall, director of the RAE, took charge of the forensic investigation. Reviewing the original engineering data, he realized that de Havilland's pre-flight testing methods contained a fatal paradox. Before the Comet ever flew, test fuselages were pressurized to 16.5 psi, twice their maximum operating pressure. This double pressure test was intended to verify extreme safety margins. But instead, applying that massive pressure artificially stretched and strengthened the metal around the window corners. This phenomenon completely concealed the microscopic fatigue flaws that would only develop under normal, lower pressure operating conditions. To find the truth, the RAE took an intact Comet fuselage, designated G-ALYU, and built a custom water tank around it. The tank measured 100 feet long, 20 feet wide, and 16 feet deep. By filling the cabin with water and then cycling the pressure to simulate the exact 8.25 psi differential of a standard flight, they could safely replicate high-altitude cyclical fatigue without risking another explosion in the sky.
In mid-1954, the water tank testing commenced. The pressure cycled up and down, day after day. Finally, after 3,060 simulated pressure cycles, the test fuselage failed violently. The massive tear allowed investigators to see exactly what had doomed the Comet. Stress at the 90-degree corners of the square cutouts was concentrated at 2 to 3 times the level of the surrounding fuselage. But the forensic analysis uncovered a major contradiction to the popular narrative. While public consensus often blames the square passenger windows for the crash of Flight 781, official RAE findings established that the fatal crack actually originated at a rivet hole near the roof-mounted Automatic Direction Finder, or ADF, navigation window hatch. The root cause was a seemingly minor manufacturing change. De Havilland's original engineering design had called for glued skin seams. However, during manufacturing, the factory substituted drill riveting with punch riveting. Punching the rivets into the aluminum caused microscopic tears around the holes. Combined with the severe stress concentrations at the corners, these microcracks widened with every flight cycle until the airframe catastrophically failed. Between October 19th and November 24th, 1954, Lord Cohen presided over the formal court of inquiry in London, alongside Air Registration Board Chairman Lord Brabazon of Tara, finally giving the victims' families the mechanical truth.
When the inquiry concluded, the de Havilland Aircraft Company was exonerated of criminal negligence. The ruling explicitly noted that the company had been operating at the absolute boundary of contemporary engineering knowledge. They had not been reckless. Rather, they had encountered the limits of human understanding regarding metal fatigue and high-altitude flight. The Comet paid a terrible price for flying higher and faster than any commercial aircraft before it. But the rigorous forensic work of the RAE, from deep water salvage to the massive water tank, fundamentally changed aviation forever. The tragedy of the de Havilland Comet laid the essential groundwork for modern fracture mechanics, ensuring that the safe, pressurized flight we take for granted today was built on the hard-learned lessons of the first commercial jetliner.